Before you start Lesson 6, make sure you do Test B in the Test Masters. That test is about equations, and it may look a little different, but it's what you learned in Lesson 3. It's the exact same thing that you learned in Lesson 3. It'll probably be a little more challenging than Test A was, but solving those equations, those are just very important skills for you to have in order to succeed in this book as well as other books that you'll do later on. Well, this lesson is on factors and divisibility. Factors are whole numbers that can divide another whole number, and you just get a quotient that doesn't have a remainder. For example, if you did the problem 15 divided by 3, you should know that that equals 5. That quotient is just a whole number. Now if you did 15 divided by 4, that you would not get a quotient with just a whole number. It would have a remainder as well. That would equal 3 with a remainder of 3. 4, therefore, that's not a factor of 15. Let's just think about all of the whole numbers that 15 could be divided by, and you get a whole number answer. You could do 15 divided by 1, so we know 1's a factor. You could do 15 divided by 3, so we know 3's a factor. 15 divided by 5 would also work. And then 15 divided by itself, 15. So remember what a factor is. A factor is a number that you multiply to form a product. Any of those numbers, therefore, 1, 3, 5, and 15, any of those can be used as a factor to form the product 15. So you could have like 1 times 15, or just think about our commutative property. 15 times 1, you can write that either way. 3 times 5, or you can also write it 5 times 3. Those are the different ways that we can arrange these factors in order to form a product of 15. Now it's pretty easy to find the factors of a number like 15, but what if you had a number like 126 over here on the right? That's going to be a little bit more complicated to figure out all the factors of that number. Just keep in mind the definition of a factor, though. A factor, that's a whole number that divides another whole number without getting a remainder. Now what you can do is use the rules on page 35 of your book. These are called tests for divisibility. If you're not there already, go ahead and turn to page 35 in your book and look at those tests for divisibility that are at the bottom there. And let's just look at the number, or we use the number 126 and figure out what the different factors are. So just starting at the beginning of that table, that number, 2 is a factor of 126 if the last digit is even. And so in 126, 6, that's an even number. That's the last digit. And therefore we know that 2 is a factor, so we can write that down. 4 is a factor if the last 2 digits can be divided by 4. So that means the 2 and the 6. Well, 26, you can't divide 26 by 4 and get a whole number answer, so that means that 4 is not a factor. And then look at 8. If the last 3 digits can be divided by 8, so that would mean the 1, the 2, and the 6. Well, we could do that division real quick. 8 is the divisor, 126 is the dividend. 8 goes into 12 one time, and we get 4 when we subtract there. Bring down the 6. 8 goes into 46 5 times. And look, we have a remainder of 6. So 8 is not a factor. So let's continue with our test for divisibility. A lot of these you already know. Like 5, if the last digit is a 0 or a 5, it's divisible by 5. So 5 is not a factor. 10 wouldn't be a factor either because the last digit is not 0. 3 is a factor if the sum of the digits can be divided by 3. We'll look at the digits that we have there, a 1, a 2, and a 6. 1 plus 2 is 3, plus 6 is 9. So think about that 9. And the sum of the digits 9 can be divided by 3. So 3 is a factor. And 6, if the number can be divided by 2 and by 3, well, it can. Those are our two numbers that we have there. So 6 is also a factor. And then 9, if the sum of the digits can be divided by 9. Well, 9 divided by 9 is 1, whole number answer. So 9 is also a factor. So that's the first thing you should do anytime you're asked to find the factors for a certain number is do the test for divisibility. And those will give you the factors from basically 2 to 10. Now 1 and the number itself, those are always going to be factors. So we can include those, 1, and I'll put 126 over here on the right. And then all those numbers that we have figured out already, the 2, the 3, the 6, and the 9, they have to have another factor that they're multiplied by to equal 126. So all of those are factors as well. Keep that in mind when you're doing problems like this. So you'd have like 2 times 63. So 63 is a factor. 3 times 42 would be 126 as well, so 42 is a factor. And then 6 times 21. 9 times 14. So let me just put a box around all these. That number had a lot of different factors. Try to memorize those divisibility tests. That will help you from now until you are basically dead, because you're going to be doing math from now until you're dead, and you're going to have to maybe break a number up into smaller numbers, and these divisibility tests, those just help simplify the process. Now let's talk about something called the greatest common factor. And what you're doing is you're working with 2 or more numbers, and you're trying to find the factor between those numbers, the largest factor or the greatest factor that they both or that all of them have in common. For example, let's just say we were working with these two numbers, 18 and 24, and we wanted to figure out the greatest common factor between them. Well, first we need to find out what the factors are for both of those numbers. And so for 18, let's just start with 1 and 18. I'll just put the small number on the left, the bigger numbers to the right. And 24, we'd start with 1 and 24. We can always know that those are factors of any number, 1 and then the number itself. Those are always a pair of factors. Then we look at 18, we see that's an even number, so we know that 2 is a factor. 2 times 9 is 18, so 9 is another factor. And then hopefully you also know that 3 and 6 are factors. Now 24, 2 and 12, 3 and 8, 4 and 6. Those are all factors as well. Now let's circle our common factors. We have 1s. They both have a 1 in common. They both have 2s in common. They both have 3s. We're trying to find the greatest common factor. And so that would be the 6s, right? That's the greatest or largest factor that 18 and 24 have in common. Now the reason you need to figure out what a greatest common factor for 2 or more numbers is, that's for when you're working with fractions, and you'll start using this a lot more in lesson 24. You'll see how you use it when working with fractions starting in lesson 24. You need to be good at finding the greatest common factor between a pair of numbers so that you can do well when you get to lesson 24. So you have a lot of time between now and lesson 24 to learn this skill of figuring out what that greatest common factor is between two numbers. Why don't we go ahead and work some practice problems. In problem A, B, and C, all I want you to do is list all of the factors for those three numbers there. Anytime you're asked to list the factors of a number, they're asking you to list the whole number factors. Why don't you go ahead and pause the CD and list the factors for each of those numbers, and then turn the CD back on and see if you got them correct. So on A, for 16, you can always write down the number and 1. We know those are factors, and we see that it ends in a 6. So 2 and 8, those will both be factors. 2 times 8 is 16. And of course 4 is a factor. 4 times 4 is 16. Now, we don't have to write 4 twice on that. You can just write 4 one time. 17 is something called a prime number. It's only divisible by 1 and itself. That's it. And those are the only ways you can get a whole number product or a whole number quotient if you divide it by 1 or divide it by 17. So we just write 1 and 17 down. And then 18, 1 and the number, ends in an even number, so 2 is going to be a factor. 2 times 9 is 18. 3 times 6 is also 18. And then we would stop there. Now, it doesn't matter if you list your answer in increasing order of factors, like you could have put 1, 2, 3, 6, 9, and 18, or do it like I had it there. I mean, that doesn't matter how you write your answer down. Just it's only important if you have all of the correct factors for that answer. Now on D, E, and F, what I want you to do on those is find the factors just from 1 to 10. So in other words, use your test for divisibility on page 30 in your textbook to figure out the whole number factors between 1 and 10 for those three numbers. Now we always know that 1's going to be a factor. So on D, we can put 1 down for sure. Then just go through your tests for divisibility. And again, like I said, you should memorize these tests. The last digit is even. 0 is an even number, so 2 is going to be a factor. The last two digits cannot be divided by 4, because 50 divided by 4, you don't get a whole number remainder. I mean a whole number quotient without a remainder. And it cannot be divided by 8 either. The last three digits cannot be divided by 8. So you're looking at 0, 5, and 0. What you would say is just 50 on that. You don't really worry about the 0 in front of it. You'd say 50 divided by 8. So 50 cannot be divided by 8. The last digit is a 0, so this number can be divided by 5. So 5 is a factor. 10 would also be a factor because it can be divided by, or the last digit is a 0. So that means it can be divided by 10 and get a whole number quotient. Now it's divisible by 3 if the sum of the digits can be divided by 3. Add the digits up, 1 plus 0 plus 5 plus 0, that'd be 6 divided by 3, that equals 2. That means 3 is a factor. And then 6 is also a factor since 2 and 3 are factors. The sum of the digits cannot be divided by 9. You'd have 6 over 9. That doesn't give you a whole number quotient. So those are our numbers from 1 to 10 that would work. 1, 2, 5, 10, 3, and 6. Let's go on to E. We have an even number here. Well, we always start with 1. We have an even number, so we know 2 will work. And then 4, if the last two digits can be divided by 4, so that'd be a 0 and a 0. Well, 0 divided by 4 equals 0, which is a whole number. So then it can be divided by 4. It can also be divided by 8 because the last three digits are all zeros. And again, 0 divided by 8, that equals 0, which is a whole number. So it can be divided by 8. And then it can be divided by 5 and 10, since that last digit is a 0. And now let's think about 3. If the sum of the digits can be divided by 3, well, 4 plus 5, that equals 9. 9 divided by 3. 3 is a factor. It can be divided by 6, or 6 is going to be a factor since 2 and 3 are factors. And then it can also be divided by 9, so 9 is a factor. Since 9, which is the sum of the digits, 4 plus 5, divided by 9 equals 1, a whole number quotient. And so all of those numbers, 1, 2, 3, 4, 5, 6, 8, 9, and 10. Now, on our test for divisibility, what number between 1 and 10 do we not have a test for? That's a 7. On E, practice problem E, we had all of those numbers except for 7 we saw were factors of 45,000. Now what you need to do to figure out 7, you just have to do the division. And that's something we kind of forgot to do on practice problem D. So let's do that real quick. You need to know if 7 is going to work or not. So let's just do the division. You just kind of have to do it the hard way to figure out 7. 7 goes into 10 one time. Bring down to 35. 7 goes into 35 exactly 5 times. Bring down to 0. 7 goes into 0 0 times. And we don't have a remainder on that. So 7 is actually a factor in practice problem D. We need to include 7 in our answer. So be careful about 7. It's not in the test for divisibility. Every other number, well, 1's not in there either, but 1 is easy. 7 is, you've just got to do the division to figure out if 7 is a factor. Or, like, look at practice problem F. 6,300. Hopefully you know that 9 times 7 is 63, so you know that 7 is going to be a factor. If 9 times 7 is 63, then 900 times 7 would equal 6,300. So on practice problem F, let's just start listing our factors. We know that 1 would be a factor, 2 since it's an even number, 4 since the 2 digits there at the end can be divided by 4. Now 8, if the last 3 digits can be divided by 8, 300 divided by 8 does not give you a whole number remainder or a whole number quotient without a remainder. So 8 is not a factor. 5 would be a factor since it ends in 0, so would 10. Then 3, that would be a factor. Add the digits up, 6 plus 3 plus the zeros, that'd be 9. 9 divided by 3 is 3, a whole number quotient without a remainder. So 3 works, 6 works since you have 3 and 2 in there. 9 would work, and then we have to remember 7, which we were talking about earlier. So those are all factors between 1 and 10. That's what we were trying to figure out on D, E, and F, is just the factors between 1 and 10 for those numbers. Look at practice problem G. It's the same thing you've been doing, it's just worded a little bit different. It says list the single digit divisors of 1412. Well, isn't a divisor, if you have a divisor and you get a whole number without a remainder, that's a factor. That's what we've been talking about. That's the definition of a factor. A factor is a whole number that divides another whole number without a remainder. So another way you can think about that is a factor is a whole number that's a divisor of another whole number without a remainder. If you see another problem like this, just do your divisibility test. That's all you have to do. And the single digit divisors that would work then, 1 will always be one of those. 2, since it's an even number. The last 2 digits, 12, can be divided by 4. 12 divided by 4 is 3. So 4 is a factor. If the last 3 digits can be divided by 8, then 8 is a factor. You just have to do the division. You just have to go over to the side if you're not sure and do that division. 8 goes into 41 5 times. 8 goes into 12 once. And so we can see there we're going to get a remainder. So that's not going to work. 8 won't work. Now it doesn't end in 0, doesn't end in 5. So 5 or 10 are not going to be divisors. If the sum of the digits can be divided by 3, let's just add them up. 1 plus 4 is 5, 6, 7, 8. 8 divided by 3 doesn't work. So 3's not, it's not divisible by 3. 3's not a divisor. So 6 wouldn't work either. 9 won't work either. So these are our only 3. We have to do 7 though. We just have to do the division to figure out if 7's going to work. 7 goes into 14 exactly 2 times. 7 doesn't go into 1. So we put 0 up there. Bring down the 2. 7 goes into 12 once. And we can see there what we will have a remainder. So 7 doesn't work. And all we get for divisors, single digit divisors, are 1, 2, and 4. Look at practice problem H. 8,000 is divisible by which single digit numbers? Again, just worded a little bit differently than saying just find all the factors of a number, but it's the same thing. When you hear the words divisibility or find the factors, you just have to recognize that that's all you're doing is using your test for divisibility to figure out what the different factors are. So 8,000 is divisible by which single digit numbers? Well, we know 1 is going to work, 2 since it's even, 4 since the first 2 digits or the last 2 digits there are zeros. 0 divided by 4 is 0, which is a whole number. 8 is going to work, not just because it's 8,000, but because the last 3 digits there are 0. 0 divided by 8 is 8. 5 will work. 10 would work too if we're just looking at our test for divisibility, but answer the question. It says is divisible by which single digit numbers? So we don't have to worry about 10. Now the sum of the digits is not divisible by 3, so 3 won't work. That means 6 won't work. 9 won't work either because the sum of the digits cannot be divided by 9. And this one, it's pretty easy to tell that 7 is not going to work. It'd have to be 7,000 for 7 to be divisible by it. You can go ahead and do the division if you want to just to check it yourself, but 7 won't work on that one. And so those are the numbers 1, 2, 4, 8, and 5. And remember too on these problems to answer the question. The question, all they wanted were single digit numbers. They don't want 1 and 8,000, 2 and 4,000, 4 and 2,000, 8 and 1,000, and so on. That's not what they wanted there. They just wanted single digit numbers. Now let's do some greatest common factor problems. In I and J, I want you to find the greatest common factors between those two numbers. Hopefully you've had enough practice with divisibility now and finding factors that you could easily find the greatest common factor between those two numbers. So why don't you go ahead and pause the CD and work I and J. Turn it back on and check your answers. On I, we're comparing 15 and 18. What I like to do on these when I'm finding a greatest common factor is just write the smaller factors to the left and the larger ones to the right. So I think 1 and 15. 2 wouldn't be 1. 3 and 5. And that's it for 15. And then 18, I'll have 1 and 18. 3, well 2 and 9 actually. 3 and 6. And that's all for 18. Now the greatest common factor, that wouldn't be the ones, it'd be the 3's, right? Those are 3's, they both have a 3 in common, and they both have a 1 in common too, but 3 is the greater of those common factors, so that is the correct answer, 3. Now 24 and 36, let's just think of 24, we'll have 1, 24, 2 and 12, 3 and 8, 4 and 6, and that's it. 36, we'll have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then just a 6. We don't have to say 6 and 6. Now let's just go ahead and look at those. They have 1's in common, 2's, 3's, 4's, 6's, not 8's, not 9's, 12's. 12 is the greatest common factor. So that would be the answer there. The greatest common factor between 24 and 36 is 12. Remember, you're going to need to know how to find the greatest common factor later on in lesson 24, it's where you'll start applying the use of the greatest common factor when you're working with fractions. Okay, well that's all for lesson 6. If you need more practice, do the practice problems that are in the book. This lesson also has some supplementary practice problems in the appendix in the back of the book. So you might want to go back there and do those too if you need extra help, beyond just my practice problems and the problems on page 31 for that lesson.